So question 1 part A is a graph theory question. So we're given an adjacency matrix and it's representing a directed graph. So remember, if it's a directed graph, it's not going to be symmetrical through the top left to bottom right diagonal. For example, you can see this entry here is not the same as this entry here, but if it was not a directed graph, they would both be the same, because the number of ways to go from B to A would be the same as the number of ways to go from A to B. But because it's a directed graph, this is not the case. So remember, we read from left to top, and that's each entry represents the number of edges from one node to the other. So if we look A, so A to A, there's one edge that goes from A to A. So we can draw a little loop. And remember, since this is a digraph, we have to draw in a little arrow as well to show the direction. Now from A to B, there are two edges, so we can draw one like this. And we can draw the other one like this. The way you draw them doesn't matter, but it is important that you have the arrow to show that it's going from A to B and not the other way around. Now we have 0 from A to C, and we have 1 from A to D, so we can draw 1 here down to D. Obviously, you might want to use a ruler if you're doing this in the real exam, but it's a little bit more awkward on a computer, but I'm just freestyling them. And then from A to E, there's nothing, and from A to F, there's nothing. Now we have a look at B, 0, 0. From B to C, there's 1. So we'll draw 1 here from B to C. And then there's 1 from B to F as well. So this gets a little bit messy, but we'll draw it through here. And we'll draw the arrow to show it's going from B to F. Now we're moving on to C. C, there are a lot. So we have 1 going from C to A. So we can draw that in here. 1 going from C to A. We have 1 going from C to B. So we can draw 1 like that. 1 going from C to C, so we're going to have a loop with a little arrow. 1 going from C to D, so we can draw 1 down there. 2 going from C to E, so we can draw 1 here. And then just to make it a little, we'll go around here just so we're not clustering up the middle. So there's a 2 to E. And we have 0 to F, so we can move on. For D, we have 1 edge going from D to F. So where's D? Here's D, and we have 1 edge going from D to F. From E to E, we have 2, so we're going to have 2 loops. So there's 1 loop, and there's another loop. It's a little bit small, but hopefully you can see that. And for F, we have 1 going from F to B. So I'm just going to draw it all the way around from F to B. So yours might look a little bit different because it doesn't matter where you're drawing the edges, but that's just the way I drew it. As long as you have the correct number going from one node to the other, you'll be fine. So part 2 asks us to write down a cycle which starts at node B. So remember, a cycle is a closed walk with no repeating nodes, and it starts and ends at the same point. That's what closed means. So if we have a look here, one that starts at B and ends at B, well, you could go from B, we'll do this in red just to show, go from B down here to C, and then back to B. So that's a valid one. You'd write that BCB. Or another one, for example, you could go from B to C, then go from C to A, and then you can go from A to B. So you could write that one if you wanted to do that one as B, C, A, B. Either of those are correct. It's up to you. There are tons of other options as well. It's up to you which one you want to do. Part 3 asks us, how does a directed graph differ from an undirected graph? Well, I suppose there are a few correct answers. Of course, we don't have the marking scheme, so we can't be sure. But one way, as I mentioned, is that it won't be symmetrical through the top left to bottom right diagonal. So we can write that. Or maybe you could write down a few things like that it won't be symmetric and that each edge has a direction and you can only go from in one direction and all that. Of course, it's a good habit usually to write down as much as you can, but I'd say that'd be enough, but we'll see when the marking scheme comes out. Part B was an integration by parts question. So we're given an equation. So a particle moving in a straight line has a velocity v, and v is the time derivative of displacement. And it's given by the equation 2t e to the minus t, and t is greater than or equal to 0. So we're instructed to use integration by parts or otherwise, although I'm not sure how you could do it otherwise using the methods on the applied maths course. Derive an expression for s of t, the displacement of the particle at any time t. So there are two ways of doing this technically. The way that they show in the book and in most applied maths resources is this formula, this integration by parts formula, which is in your formulae and tables book on page 26. I prefer to use another way, but because a lot of students would probably use this way, I'll show this way, then I'll show my preferred way. So if we're going to use this way, well then, first of all, we state the formula. It's up there already, but if this were the exam, you'd state it, just in case you mess something up. The examiner can see that you're using the right formula. Now we need to choose something to be u and choose something to be dv. So remember, u is going to be something that we differentiate to get du. So we differentiate the u part to get this du. And then the v is going to be the part that the dv is what we integrate to get the v. So we have to choose a u and a dv from this. So we have ds over dt equals 2t e to the minus t. So I'm going to choose to differentiate 2t. This is going to be my u, because I know if I differentiate 2t twice, we're eventually going to get to 0, which is what we want. If we were to instead differentiate e to the minus t, we'd keep going forever, because the derivative of e to the t just keeps looping forever. And then if we kept integrating 2t, we'd just keep getting bigger and bigger powers. It would never end. So that's why I'm going to choose to differentiate 2t and integrate e to the minus t. Maybe you'd prefer to use the in late rule or the Liate rule. It's up to you. I don't really use that rule personally, but if you want to use that, you can. So I'm going to let my u equals 2t, which means that du dt will be 2, which means that du equals 2 dt. So we're going to let our dv now equal e to the minus t, because that's the other part. And remember, when we're integrating this now, whenever you have e to the ax, you're going to have to multiply by 1 over a. In this case, our a is minus 1, so that's just the same as saying minus e to the minus t. So now we can combine those two parts together. So the integral of 2t e to the minus t dt, that's going to be u, which is 2t, multiplied by v, which is minus e to the minus t, minus the integral of v, which is minus e to the minus t, times du, and our du was 2 dt. So times 2 dt. Now we can simplify this a little bit. So we can bring the minus at the front here. Minus 2t e to the minus t. The minus and the minus will make a plus, and we have the 2, which is a constant, so we can take it outside the integral, or you can leave it inside, it doesn't matter. But anyway, plus 2 times the integral of e to the minus t dt. So now we just have one more integral to go. And remember this, what we're doing here when we're integrating, we're getting s by itself. So here we're getting our displacement function s of t, because what we did is we integrated this equation. So when we integrated it, undoes the derivative, it gets rid of the d dt, leaving us with just the s. So that's what s of t is. Now we have to do this last integral. So we get s of t equals minus 2t e to the minus t. Now the integral of e to the minus t, we had it over here as well. It's going to be minus e to the minus t. So we're going to have minus 2 e to the minus t plus c, of course. Now we're given some information. We're told that s of 0 equals 0. So that means that when t is 0, s will be 0. So that means we have 0 equals, so 2t e to the minus t, that's just going to be 0, minus 2e to the 0 plus c. 0 equals minus 2 e to the 0 is 1, because anything to the power of 0 is 1. So we get minus 2 plus c, which means that c has to be equal to 2. So now finishing it all off, we get s of t equals minus 2t e to the minus t minus 2e to the minus t plus 2. And that's it. You could factor out minus 2 e to the minus t if you want, but it's not necessary, I don't think. That's simple enough. Now, my preferred method, and the one that I would encourage you to learn because it's way faster, especially given the time constraints on the applied maths exam, it'll really help you out, is called the DI method for integration by parts. So what do we have? We have ds over dt equals 2t e to the minus t.
So what we're trying to integrate is this 2t e to the minus t. So what we do is we write down d, we write down I, and we write down plus, minus, plus, minus. You might need to do more, but I just do 4 usually at the start. And now we choose a part to differentiate, and we choose a part to integrate. So as with last time, for the same reasons, we're going to choose to differentiate 2t and integrate e to the minus t, because that 2t will eventually go to 0, which means that we're going to come to an end. If we integrated to 2t, it would keep going up and up forever, and if we differentiated e to the minus t, it would keep going on forever, so we'd never get a final answer. So now we just differentiate. So differentiate 2t, we get 2, differentiate 2, we get 0. Now integrate e to the minus t, we get minus e to the minus t, integrate it again, and we get e to the minus t. Now what we do is we draw diagonal arrows, and we multiply those. So s of t, which is what we're solving for, equals, what's 2t times minus e to the minus t? We get minus 2t e to the minus t. And now we have 2 times e to the minus t, but remember, there's this minus here, so we're going to have minus 2 e to the minus t, and then plus c. See how much, you might need to pause that and rewind, but see how much quicker that was? It's a lot better than the traditional integration by parts formula. Anyways, we know s of 0 will be 0, so we have 0 equals 0 minus 2 e to the 0 plus c again, which means that c will be 0, or sorry, c will be 2, which means that our final one, s of t, and this time I'll show the factorization, you can factor out a minus 2 e to the minus t, and then you'll get t plus 1, and then plus 2. So again, I don't think it matters if you factor it out, but that is a little bit nicer, I suppose, so you can write it like that if you want. So now in the final part of this question, it asks us to calculate s of 3, which is easy enough. We just replace all of the t's with a 3. So s of 3 equals minus 2 e to the minus 3, because we're replacing those t's with 3's. And then multiplied by 3 plus 1. Then we're just adding the 2 at the end, and that'll give you an answer of about 1.602 to 3 decimal places, just because I usually do 3 decimal places. And it actually doesn't give us a unit up here, just says it has a velocity, it doesn't say meters or anything. So instead of writing meters, I would just write units. Again, we don't have a marking scheme yet. I doubt they'd mark you down for writing meters, but I wrote units just in case. And that's all of question 1.